This video is for lesson 70, solving for exponents. I wanted to start off with the steps that we can use in order to solve these. These are guidelines more than exact instructions on how to solve any one of these, but I'll go with an easy example first. So the process we want to do is we want to isolate the exponential term, meaning get it by itself. Then we want to log both sides. That'll allow us to bring down the exponent, and then we can divide to solve. Now, in this case, for question number 12, 11 to the x power equals 71. The exponential term, right, the term with the exponent on it, is already isolated. So all we have to do now is log both sides, bring down the exponent, and divide to solve. And we'll need a calculator for this. Well, if I log both sides, I get log of 11 to the x is equal to log of 71. This allows me to bring down the exponent into the front. So now we have x times log of 11 is equal to log of 71. The x is attached to the log 11 with multiplication, and I want to get x by itself, so I divide off the log 11. What I do to one side, I have to do to the other as well. So I get x is equal to log of 71 over log 11, which I'll do in the calculator. Log of 71 divided by log of 11. Enter, and we want to keep 3 decimal places. So the answer to this is going to be 1.778. Right, the 6 being cut off, 6 is 5 or greater, so it'll round up the next number. So 7 becomes an 8. 1.778. And that's x. Okay, now we'll do one that requires a few more steps. It just requires that we flex our equation solving muscles, and we also need to isolate the exponential term first. Now, isolating the exponential means this. This is the only term that has the exponent on it. So let's isolate it. The way that I isolate it is by getting rid of the other stuff by using its inverse operations. In order to get rid of a minus 9.6, I'm going to add 9.6. Whatever I do to one side, I do the other. These cross out. I get 7 times 8 to the 3k minus 3 is equal to 43.6. Still not isolated yet. I'll get rid of the times 7 by dividing by 7. Do that on both sides. I get 8 to the 3k minus 3 power is equal to, I'm going to want to go to the calculator for this, 43.6 divided by 7. I'll clear that. That's equal to 6.229. Keep 3 decimal places throughout the whole process. 6.229. And now it's isolated. The left-hand side is isolated, the exponential term. So what I'm going to do now is I'm going to log both sides, which allows me to bring down the exponent and put it in front. What I have now is 3k minus 3 times log of 8. And that's equal to log of 6.229. Okay. Now my goal is still to solve for the variable. It's to solve for k. So I need to undo everything else that's going on the left-hand side. I need to get rid of the log 8, I need to get rid of the minus 3, and I need to get rid of the times 3. I'm going to do that from the outside in. The easy one to get rid of right now is going to be divide both sides by the log 8. And now they're gone. I get that 3k minus 3 is equal to, this, whatever that is. I'm going to figure out what that is in the calculator. Log of 6.229 divided by log 8. Log of 6.229 divided by log of 8. Make sure that you're always closing your parentheses. And we get 0.8796, 0.87, and the 9 will round up. So this is actually going to it's going to work like this. 0.8796 becomes this. So 0.8796. When I cut off the 6, it rounds the 9 up. That 9 becomes a 10. So this actually becomes 8 and 7. 1 and 7 is 8. So this becomes 0.88. Okay? That's what this is equal to. Now what I have to do on this is I'm going to add 3. Add 3. I get that 3k is equal to 3.88. And lastly, I divide both sides by 3. And I get that k is equal to 3.88 divided by 3. 1.293. And that's x, or k. Okay, so it's a lot of steps, but it's better to be prepared. This could come up with even more steps on a regent, so I would much prefer you be prepared with it now. So let's go over what we did. We identified what term was the exponential term, and we isolated it by getting rid of everything around it. So we added the 9.6 to both sides. We divided both sides by 7. Now it's by itself. Once it's by itself, you're allowed to log both sides in order to bring down the exponent. The exponent comes down in a set of parentheses attached to the front with multiplication. You divide off the log on both sides to get rid of it, and then you just solve for the variable regular style. If you have any more questions with that, you can see me in office hours, or you can rewatch that question. Good luck.